Hello everyone. In this video I would like to start talk about free fall. Let's say we have ground and we have some object. Let's say initial position would be h equals 100 meters above the ground, and we will lose this object, and it will probably will fall towards the ground. Why we talk about free fall? Because and when we can say that objects actually perform free fall, when the only force that applied on those objects or object is only gravitational force that comes from the earth. Okay, the only this. Okay, and therefore we have constant acceleration towards the ground, and the name of this acceleration is g, from the word gravitation, and the magnitude is 10 meters per second squared, and we assume that this acceleration, gravitational acceleration, is constant when the maximum height above the ground is approximately 100 kilometers. And when we talk about above this height, okay, then we will talk about another subject. But at this particular subject, we will assume that we are uh, in this interval between 0 and 100 kilometers. Okay, we can assume that the acceleration is always constant, and direction is always constant towards the ground. Now, this subject is almost the same as was in the previous videos. We have constant acceleration, therefore we will have a linear function of velocity and a parabola function for position. Now, because the movement is perpendicular to the ground, we will use a y-axis. Now, the direction of y you can choose upwards or downwards. Okay, let's say in this particular problem we will use direction of y-axis towards the ground, and we also choose, let's choose initial position, also the origin of the axis, y equals y0 equals 0 meters. Okay, also let's assume that initial velocity is v0 equals 0 meters per second. Okay, let's ask what is function, or find v of t. Okay, find v of t, and solution, because if we know that acceleration is constant, okay, then we can use this formula. V of t equals v0 plus a t minus t0. Now, instead of a, I will substitute this with g. Initial velocity is 0. Initial time would be also 0 seconds. Now, the sign of acceleration would be plus, because the direction of this vector, okay, is the same direction as y-axis. So, therefore, we get this expression for velocity: 0 plus g times t, vt equals g times t, or v of t equals 10 times t, which is actually linear function. We can draw easily. Let's say draw graph of v of t. It's like when we talked about mathematics, it would look like something like this: 10 times x, which is linear function, very easy to draw. Let's assume this is our v-axis, v of t, time axis, seconds, and it would look something like this. Now the slope of this function is actually acceleration, delta v, delta t, and a equals to delta v divided by delta t, which is actually gravitational acceleration, g. Okay, what else can we ask? Part C. Find y of t, position function. Again, we will use this formula: y0, initial position, plus initial velocity times t minus t0, plus g divided by 2 t minus t0 squared. As we used in previous problems, we used xt equals x0 plus v0 t minus t0 plus a divided by 2 times t minus t0 squared. Okay? The same, because we know that acceleration is constant. Okay, so let's substitute parameters or values that we know. Okay, initial position, we know it's 0. Initial velocity, 0 times t, because this 0 also 0 seconds. Okay, plus 10 divided by 2 times t squared. Finally, we have position function of object, which equals to 5 times t squared, which is parabola. It is happy parabola because the coefficient is positive. Now let's draw this function d. Draw graph of y of t. It's actually very easy to draw. This is y, t, meters, these are units, t, seconds. Okay, now we know that when we're talking about instantaneous velocity at any given time, and actually the instantaneous slope or tangent of the particular time is actually instantaneous velocity. Okay, and we do know that when this object begins to fall, the initial position is 0, which means instantaneous velocity is actually 0. v t equals 0 seconds equals 0 meters per second. So our parabola will look something like this. Now, because we are talking about t greater or equal to 0 seconds, then we don't need to draw this part of the parabola. So eventually we need only draw this part of the parabola. This is how this graph of y of t looks like. What else? E. We can ask how much time it takes to this object to get to the ground. Okay, to answer this part, we need to use this function. Okay, function of position. So find the time that took to fall to the ground. Okay, so y of t equals 5 times t squared. Now, when this object reaches the ground, the position of this object equals to the 100 meters. Okay, which means I will substitute y of t by 100 equals 5 times t squared. Let's divide it by 5. T squared equals 20, and t equals 5 times 4, which equals 2 times square root of 5 seconds. Okay, this is amount of time that actually this object is actually acts as a free fall object, or how much time it takes to the object to reach the ground. What else we can ask? Okay, A, B, C, D, E, F, part F. What is the velocity of the object when it reaches the ground? So to answer that, of course, we're going to use this function v of t, which equals 10 times t. Okay, now we know the time that it took to this object to reach the ground, so we're going to substitute this value of 2 times square root of 5 here, and let's see what we'll get. The velocity when this object reaches the ground will equal to 10 times 2 times square root of 5, 20 times square root of 5 meters per second. So it's not that actually hard to answer all those questions, because previous subject, it's actually almost the same as this one. Only the difference is that the acceleration is constant and the direction remains always to the ground, towards the ground. Okay, I think it's enough for this problem. Okay, we have enough parts. Okay, so I will see you in the next videos. Thank you very much. Have a nice night or a day.